Dear students, welcome back to the today's session. We will continue our discussion what we had in the previous session. And in the previous session, we had solved this problem and we had come to the stage of getting the bending moment at each and every end. We obtained the bending moment. The moments are on the screen here. Now we will continue the discussion on how to complete the bending moment diagram and how to complete the shear force diagram. So let us first do the bending moment diagram. For bending moment diagram, you need to first draw the free bending moment diagram for the entire knee. So I am going to do that. Draw a horizontal line, and the free bending moment diagram here is a parabola. Free bending moment diagram means considering this as a simply supported beam, and the coordinate is WL square upon 8. WL square upon 8 is 40 into 6 square divided by 8. That comes to 180 kilonewton meter. And here the bending moment coordinate is WL by 4 because the load is at the center, so the bending moment coordinate is WL by 4. So this is WL by 4, 160 into 4 by 4, that is 160 kilonewton meter. And then let us superimpose these moments which are obtained by solving. So let us first write out. These are all hogging moments. You can see MAB, it is anti-clockwise, MBA clockwise, MBC anti-clockwise, clockwise. So let us mark here MAB anti-clockwise, MBA clockwise, MBC anti-clockwise, and MCB clockwise. So anti-clockwise here on the left side of AB, hogging. Clockwise on the right side of AB, hogging. Again, anti-clockwise here on the left side of BC, hogging, and clockwise on the right side of BC, that is MCB, again hogging. That means all the moments are hogging in nature. So what we do, this is the sagging moment bending moment diagram. Now over that hogging will be superimposed. MAB 145. So this is 145.61. MBA 68.8, only one line, MBA and MBC 68.8, and that is also hogging. 68.8. And then MCB 160, that is also hogging. So what we will do, we will join these hogging values or hogging ordinates, and we will hatch the resultant portion. So this is the resultant bending moment diagram. This is 160 kilonewton. So this is your bending moment diagram. So this is complete BMD. I hope you have understood the concept of drawing bending moment diagram. We have done 3 problems. So I will explain once again what I have done. First, what I have done is I have drawn the free bending moment diagram, parabola and a triangle. The parabola coordinate is 180. How do you have obtained 180? WL square upon 8. The ordinate of triangle is, that is triangular bending moment diagram free. The ordinate is WL by 4, 160. Then superimposing the hogging moments. All the moments are hogging. Hogging 145.61, hogging 68.6, hogging 160. So we superimpose hogging over the sagging value, and then we join these hogging values, and then show the hashed line as the resultant bending moment diagram. This is the concept of drawing BMD. So you can call this as hogging. This is sagging, hogging, sagging, hogging. That means this hashed diagram is the resultant hogging diagram. This is sagging diagram. This is hogging portion, sagging portion, and this complete is hogging portion. So this is your BMD or bending moment diagram. Okay. Now let us go and do the shear force diagram. I will draw a horizontal line as usual. Then what I will do is I will first show the free reactions. You may ask me why these free reactions and how these free reactions. I have already explained in the previous session. What is this free reaction? Consider AB as simply supported beam. Free reaction, each free reaction is equal to, because it is UDL, WL by 2. 40 into 6 by 2, WL. 40 into 6 by 2, it is going to be 120 kN. And this is also 120. 40 into 6 is 240. Divided by 2 is 120 kN. 120 kN. And then the free bending free reactions for the BC beam or for the BC span is, the load is 160 concentrated load. So it is W by 2. 160 by 2, 80, 80. 160 by 2 is 80, 80. Symmetric loading. And then there is 80 kN overhanging portion that will be supported by this support only. So extra 80 will come here because this 80 should be supported by this support only, support C. So extra 80 comes. So these are the free reactions. Now these are called free reactions. Now unbalanced moment. What is moment here? Moment here is 145.61 anti-clockwise. Moment here for this tank is 68.6. So 145.61 anti-clockwise and 68.6 clockwise. So the difference of the two, 145.61 minus 68.8. This is anti-clockwise, this is clockwise. So the resultant moment is anti-clockwise. The value is going to be 76.81. 76.81 kilonewton meter. Or you can write down here 76.81. If you want, you can, instead of writing here, you can write here 76.81 kilonewton meter. The next one is, here you can see it is 145.6, 61 and, sorry, not 145, 68.8, and here it is 160. The difference of the two, that is 160 is bigger clockwise and then 68.8. The difference of the two is clockwise. How it is obtained? Clockwise is 160 minus 68.8, that comes to 91.82, 91.20. So 76.81 and 91.2 I have already done. Now these are called unbalanced movement. Now these unbalanced movements are to be balanced. How they are to be balanced? This is anti-clockwise. So there should be a clockwise couple to balance this. And the value of couple is given by moment divided by span. That is 76.81 divided by span 6 meter. That comes to 12.8 kilonewton. Now the moment here is clockwise, so you need to give anti-clockwise couple to balance this. The moment is clockwise, so you need to give anti-clockwise couple to balance this. Each reaction will be equal to 91.2 divided by 4. 91.2 divided by 4, it becomes 22.8. 22.80. Now sum of them and get the final reactions. The final reactions are 132.8, and then 164.4, 164.40, and the last one is 182.8. These are the final reactions. So using these reactions, now we are going to draw the shear force diagram. I hope you have understood. If you have not understood, I will explain once again. Just look here how to draw the shear force diagram, because this is very important concept and you have to use this concept in all the problems, in all the modules. First, free reactions. The load is 40 UDL, 40 into 6, 240 divided by 2, WL by 2, 120, 120, free reactions. The free reaction load is 160. 160 by 2, that is 80, 80. And that additional 80 is supported by this. So these are free reactions. 120, 120, 80, 80, 80. Then unbalanced moment 76.81 145.61 and 68.8. The difference of them anti-clockwise. The difference of these two moments, you can see MBC is 68.8 and MCC is 160. 160 is bigger. So 160 minus 68.8 becomes 91.2. So these are unbalanced moments. This unbalanced moment is anti-clockwise. So you have to give clockwise. Clockwise, you can see reaction up, reaction down, clockwise. So each reaction is equal to unbalanced moment divided by span 6. Each reaction is here also equal to unbalanced moment divided by 6. You can see clockwise moment here. So you need to do anti-clockwise. So 22.8 is nothing but 91.2 divided by 5. Then add the algebraic. How you have 120 plus 12.8. This is 132.8. 120 plus 80 minus 12.8 minus 22.2. So it is going to be, this is clockwise and this is anti-clockwise. So you just add them, you are going to get the values of the final reactions: 132.8, 164.4 and 182.8. So these are the final reactions. Now using these final reactions, we have to draw now shear force diagram. So drawing shear force diagram, we need to draw a horizontal line. Starts with 132.8, positive on the left side, 132.8, 132.80 kilometer. Then it drops at the rate of, because there is UDL, it drops at the rate of 40 kilonewton per meter. So the total drop is 40 into 6, it is 240. So 132.8 minus 240, the value becomes 107.2. Minus 107.2 minus 107.20 in between straight line variation because UDL minus 107.2 plus 164.4, it becomes equal to 57.2. Then it remains constant minus 160. Minus 160, it becomes minus 102.8. 80. Minus 102.80, it remains constant again. Then plus 182.8. Minus 102.80 plus 182.8, it becomes 80. 80 remains constant. Minus 80, it becomes 0. So this is your SFD. I will just explain how I have drawn the SFD. First, 132.8 starts with upward positive left side, drops at the rate of 40 per meter. So 132.8 minus 40 into 6 to 40 minus 107.2 minus 107.2 plus 164.4, sudden rise, it becomes plus 57.2, remains constant. Sudden minus 160, it becomes minus 102.8, and then again remains constant. Sudden 182.8 up, it becomes plus 80. Plus 80 remains constant. Sudden minus 80 becomes 0 here. So this is your shear force diagram. So this is how we conclude this session. So we will meet in the next session and we will see some more problems. I will stop here. I hope you have understood.